Hey folks, let's talk about parallel lines and triangles. Here's a triangle. Now I'm going to show you something cool. I'm going to cut off the three corners of this triangle. Oops. Gonna cut them off like so. Whoopsh. Whoopsh. And we're gonna see what the three angles of a triangle add up to. La da dee la dee da. Isn't that cool? So what you get is you get a straight angle, right? This corner over here, this angle plus this angle makes a straight line, 180 degrees. So, whoopsh, 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 180 degrees. Any triangle you make, you can watch. You could do this right now. Get a piece of paper, cut out a triangle, tear off the three corners, put them together, and they'll make a straight line down here. So the sum of the angle measures of a triangle is always the same. Hint, hint, it might be 180 degrees. Okay, in order to prove that, we need to get some information over here about these parallel lines. So through a point not on a line, there is one and only one parallel line to the given line. So you start with a line and a point. There's only one line through that point that's parallel to this line. That's the parallel postulate. Theorem 311 is the triangle sum theorem. It says that the measures of the angles of a triangle is 180. So in this picture, measure of angle A plus measure of angle B plus measure of angle C equals 180. We need this guy to prove that. Let's do it. Given any triangle ABC, prove that the measure of angle that the measure of angle A plus the measure of angle 2 plus the measure of angle C equals 180. Alright, so the first thing we're going to do is draw line PR through B parallel to AC. And we can do that given the parallel postulate. There's one parallel line that runs through the point B that's parallel to AC. Alright, so angle PBC and angle 3 are supplementary. They form a linear pair. Angles that form a linear pair are supplementary. So angle PBC is supplementary to angle 3. The measure of angle PBC plus the measure of angle 3 is 180. That's just the definition of supplementary angles. The measure of angle PBC is equal to the measure of angle 1 plus the measure of angle 2. That's just the angle addition postulate. So now we get that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 by substitution property. PBC is the same as measure of angle 1 plus measure of angle 2, so measure of angle 1 plus measure of angle 2 substituted here gives you statement 5. Well, angle 1 is congruent to angle A. Angle 1 is congruent to angle A, and angle 3 is congruent to angle C. Why? Because they are alternate interior angles between two parallel lines cut by a transversal. If lines are parallel, then alternate interior angles are congruent. Measure of angle 1 equals measure of angle A, because they're congruent angles. Measure of angle 3 equals measure of angle C, because they're congruent angles. Congruent angles have the same measure. And now I can use the substitution property to substitute measure of angle A for this, and measure of angle C for this, and then I'll have the three angles in the triangle adding up to 180 degrees by the substitution property. Now I've said what I was trying to prove, so I'm quite easily done. And if you're given some triangle and you know two angle measures, you can use the triangle sum theorem to find the measure of the third angle. So let's use it. What are the values of x and y in the diagram at the right? Well, let's see. I know that the three measures of the angles of this triangle, triangle ABD, add up to 180. So 43 plus 59 plus x has to equal 180, because those are the angle measures of this triangle. 43 plus 59 is 102, so 102 plus x equals 180, and then we subtract 102 from each side of the equal sign, and we get x equals 78. So that's 78 degrees, that angle right there. Well, let's see. Now, how could we get the measure of angle y? Well, angle ADB and angle BDC are supplementary. That means that they're going to add up to 180. So 78 plus y is 180. So if we subtract 78 from both sides, we get y equals 102. Do you find it interesting that angle y here was equal to the sum of these two angles, 43 plus 59? Did you notice that? We're going to prove a theorem about that later. It's going to be great. Okay, why don't you pause and see if you've got it. See if you can find the value of z. So we're going to use the triangle sum theorem to find z, because 49 plus 102 plus z has to equal 180. 49 plus 102 plus z equals 180. 49 plus 102 is 151. Subtract 151 from each side, and z is 29. So this is 29. And then just to double check, if we look at the giant triangle ABC, shouldn't 29 plus 59 plus this angle B, the big angle B, which is 43 plus 49, what do you think that ought to equal? Well, should equal 180, right? Let's check. 29 plus 59 plus 43 plus 49. Boom. Awesome. Also, Mouse Rat. A really cool band from TV, and also your secret phrase for the day, Mouse Rat. Okay, so let's talk about an exterior angle of a polygon. An exterior angle is an angle formed by a side and an extension of adjacent side. So here's the side, here's the extension of the adjacent side, and here is our exterior angle, angle 1. For each exterior angle of the triangle, the two non-adjacent interior angles are its remote interior angles. So this angle here, angle 1, is our external angle. 2 and 3 are the remote interior angles. And in every picture, on this side, if we extended this side, this would be our exterior angle. 2 and 3 would be our remote interior angles. And then over here we got, this is our exterior angle. 2 and 3 are our remote interior angles. So check out this theorem about the relationship between an exterior angle and its two remote interior angles, which we hinted at earlier. Theorem 312. the measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. Pretty neat, huh? Let's use that theorem. And hinty hinty, you might have to prove that theorem later. What is the measure of angle 1? Well, according to the triangle exterior angle theorem, the measure of angle 1 equals the sum of its two remote interior angles, so 80 plus 18. Measure of angle 1 is 98. 98 degrees. Your favorite band, or boy band, or group, whatever you call them. What's the measure of angle 2 here? Ooh, that's a little trickier, right? Well, the triangle exterior angle theorem says that the exterior angle equals the sum of the interior angles. So 124 equals 59 plus the measure of angle 2. Then we just need to subtract 59 from both sides. And the measure of angle 2 is 65. All right, why don't you pause and see if you got it. Okay, so two angles of a triangle are 53 degrees each. So here's a triangle. There's 53, 53, and we can use the triangle sum theorem to figure out what the measure of this angle is. It's going to be 53 plus 53 plus the measure of angle, we'll call it A, equals 180. 106 plus the measure of angle A is 180. Subtract 106, and we get measure of angle A equals 74. Now we want to know what would be the measure of an exterior angle at each vertex. So if I extend that one, if I extend this one, if I extend this one, and I call this angle 1, angle 2, angle 3, and the measure of angle 1 would be 53 plus 53, 106. The measure of angle 2 would be 74 plus 53, 127 degrees. And the measure of angle 3 would be 74 plus 53, which is 127 degrees. Cool. Alright, so when radar tracks an object, the reflection of signals off the ground can result in clutter. Clutter causes the receiver to confuse the real object with its reflection, called a ghost. So here's your ghost, and here's your real plane. At the right, there's a radar receiver at A, an airplane at B, and airplane's ghost at D. What is the value of X? Well, it looks like 80 is going to be 30 plus X, because this exterior angle is the sum of the remote interior angles. So measure of angle A, which is X, equals measure of angle B plus the measure of angle BCD. I think I just said that wrong. Measure of angle A plus measure of angle B equals the measure of this exterior angle BCD. So we're going to substitute. Angle A, the measure of angle A is X, measure of angle B is 30, the measure of angle BCD is 80. Then we just subtract 30 from each side, and we get angle X is 50 degrees. So the correct answer is B. Bubbly, 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 bubbly. Alright, so in this problem, can you find the measure of angle A without using the triangle exterior angle theorem? Explain. And the answer is, yeah, you could. And I'll show you how. Well, we know that angle BCD and angle BCA are supplementary because they form a linear pair, which means that angle BCA is 100 degrees because 100 plus 80 is 180. And we can use the triangle sum theorem to say that 30, here I'll write it down here, 30 plus x plus 100 equals 180, and that's x plus 130 equals 180, and if you subtract 130 from both sides you get x equals 50. So more than one way to do things in life and geometry. Hey, we're done. Congratulations. Bye-bye.